All right, so now we're on to skill 3. So this is new stuff. Partial pressures and mole fractions. Even though some of these questions do mention partial pressures and mole fractions, you could possibly be using a formula that you have in the past to solve them. It doesn't mean that you have to use those formulas straight from the notes. So look at what you've got and decide what would be best. But just a few things. Remember, total pressure equals the partial pressure of all the gases in a mixture added together. And so you do that for every gas in the mixture. Okay. Another formula that you need to remember is mole fraction of a gas, let's call that gas A, times total pressure can tell you partial pressure of that gas. And then mole fraction, so again, if we're looking for mole fraction of A, you would take moles of A over total moles. So those three we'll probably be using on quite a few of these problems, but not necessarily all of them. All right, so let's go ahead and start with number 1. We have 71 grams of phosphorus, and it reacts with hydrogen gas, and the only product is phosphorus trioxide. So I'm going to give you the balanced equation. It should have been given, oh no, it did. It did give it to you here. All right, so phosphorus is in the form of P4. I just didn't want you to think, like, where did that come from? So P4 reacts with hydrogen gas to make phosphorus trihydride. And so then we can go in and balance it. All right. And notice this is a solid, this is a gas, and this is a gas. It wants to know total pressure in the container after the reaction is complete. So pressure will only be coming from gases. So it doesn't matter if phosphorus is left over at the very end. Because it's a solid, it won't create any pressure. Right, so we know that we're starting off with 71 grams of phosphorus. Okay, it's going to react with hydrogen. We know the volume. We know the temperature. And the only product is this. The partial pressure of hydrogen gas before any reaction takes place is 6.13 atm. So why do you think they're telling you that? So most likely because you can find something from this information. You have 2 reactants and it's giving you information about both of them. This is going to be a limiting reagent problem. So what can we find if we know pressure of hydrogen, we know volume of hydrogen, and we know temperature that the reaction is taking place? So you should be thinking moles. So I'm going to leave this blank under here because we'll come back to this. And I'm going to solve for moles of hydrogen over here. So this is for hydrogen. Just labeling it because I guess a lot will be going on. All right, so we know pressure is 6.13 atm. Volume is 29. We're looking for N. R is 0.0821. And temperature is 300. So let's go ahead and find moles of hydrogen at the beginning of the reaction. Okay, so now I have moles of hydrogen at the beginning. I have grams of phosphorus. Let's figure out which one's the limiting, and that's because we need to know how much of the product we can possibly make. So let's plug it into the chart. If you don't do the chart, work grams of phosphorus to the product, work moles of hydrogen to the product, and then figure out which one limits you. So mass, molar mass, moles CE. Make sure you're filling them in the right spots because this one's moles and that one's mass. So 4 phosphorus are around 123.88 grams. And we'll put in our coefficients. Now work this one down. Right. So this is the limiting reactant. We should have 0 at the end, but it doesn't even matter because it was the solid. But so that means if we're looking for pressure at the very end, we need to figure out how much of this is left over and how much of this are we going to make. And then we can have total moles. Then we can find total pressure. So I'm going to move my limiting over to this column, work it up and subtract the 2. Since I don't have enough room, I'm just going to do it right underneath. So, right, EC moles. Move my limiting over here. So at the very end, we have 3.779 moles of hydrogen left over. I'm boxing that in because that means that'll exert pressure. So I moved my limiting equivalent here, worked it up, subtracted my 2 numbers. Now I'm going to move my limiting over to my product because it determines how much product I can make. But you only need to go to moles. Alright. And that's how many moles of product I'll have at the end. So I'm looking for total pressure. Pressure will equal total moles plugged into PV equals nRT. These two add together and you get 6.0715 total moles. Woo. Equals R is 0.0821 and temp is 300 kelvins. So total pressure at the end, and it's total because we have all the moles of gas, is 5.157 ATM D. Alright, so that kind of seemed like a challenge problem, but it's doable. It just took chemistry 1. And notice it talked about partial pressure. So what you really had to realize from that is pressure of one gas just comes from the moles of that singular gas, but we didn't use any of the new formulas yet. So we'll keep chucking through these and see what they all look like. Alright, so let's go to the next one, number 4, right below it. So we have a 10-liter container, we know the grams of nitrogen and oxygen in that container, and we know the temperature. Oh, excuse me. The question asks for partial pressures and total pressures in this mixture. There's several ways we could do this. So I'll explain a few ways, and then I'll just kind of do the way that I'm used to. But it's totally up to you. So the first way is you could find moles of both of these gases, and then you could find mole fraction of both of them, right? And then you could also add up total moles and plug that in to find total pressure, and then do mole fraction of each of these times total pressure. Let's see, what else could you do? You could find pressure of both of these using ideal gas law right away, add them up to get total pressure after that. So you could do ideal gas law, then you would have these two answers for pressure, and then add them up and get the P total. So it doesn't really matter which way, you can kind of decide, but we are using those new formulas up here to kind of figure out what the answer is. I guess I'll do ideal gas law for both of them and find out their individual pressures, and then add them up to find total. We don't have to bring in mole fraction, really. It's up to you. So I know volume, I know temperature, and I can get these both to moles. Then I'll use PV equals nRT and find pressure of both of these. So I'll do nitrogen first. So I'm just getting it to moles by dividing by molar mass. And now I'm going to do PV equals nRT with the information I have. And solve. And this temperature over here should be 619 kelvins. Make sure we're using kelvins. So pressure of nitrogen times the volume, 10 liters, equals moles of nitrogen, R, and temperature. So pressure of nitrogen for me, 0.477 atm. I'm going to go to my answer choices, and that eliminates A, B, and C. Right? So now I'm going to go ahead and do the same thing for oxygen, and then that'll give me my answer, but then I'll prove how to get total pressure. So now I'm going to take my grams of oxygen and do the same thing, find moles, find pressure of it, eliminate some. 1 mole of oxygen is 32 grams of oxygen. So now I know pressure of oxygen times volume equals the moles I just found. Go ahead and solve for that. And I got 0.219 atm. So going back up to my answer choices, E's out. So D's our answer. And then how did they get this? Well, remember, total pressure equals all your pressures added together. So this plus this should equal this. If you put them in the calculator, it does. That could also possibly help you eliminate some answers at the very beginning. So if you ever forget, what am I doing? Like, see if these add up to the total, and if they don't, that could help you get rid of some answers. So I'm going to stop this video here. It's a little long, and then whenever you're feeling ready for some more problems out of Skill 3, come on back.